How do pressure sensors actually measure pressure? Imagine feeling the weight of a glass of water in your hand. That first pressing down is similar to what pressure sensors detect inside machines and devices. They don't just sense weight, they measure how gases or liquids push on a surface. The way they do this is fascinating and involves turning physical force into an electrical signal that electronic systems can read. Most pressure sensors work by using a small mechanical part called a diaphragm or membrane. When pressure hits this part, it causes it to bend or deform slightly. Think of pressing on a soft rubber sheet. It changes shape just a little. This tiny change is what the sensor detects and uses to figure out how much pressure is present. One common type of pressure sensor uses something called a strain gauge. These are tiny resistors bonded to the diaphragm. When the diaphragm bends, it stretches or compresses the resistors, changing their electrical resistance. This change is very small, so it's usually put into a special circuit called a Wheatstone bridge. This circuit makes tiny resistance changes easier to measure. The electrical signals are then amplified and processed to give a clear reading of the pressure. Another type is the capacitive pressure sensor. It has a capacitor made of two plates. One plate is fixed, and the other is a flexible membrane. When pressure pushes on the membrane, it moves closer or farther from the fixed plate. This change in distance alters the capacitance, which is how much electric charge the capacitor can hold. The circuit measures this change and converts it into a pressure reading. Piezoelectric sensors are also popular. They use crystals that generate an electric charge when squeezed or deformed. When pressure presses on the crystal, it produces a tiny electrical charge proportional to the force. This makes piezoelectric sensors great for measuring quick or dynamic pressure changes. Inductive pressure sensors work with a magnetic core attached to the diaphragm. When pressure moves the diaphragm, it shifts the core inside a coil. This change in position affects the magnetic field and alters the voltage induced in the coil. The circuit reads this voltage change to determine the pressure. In all these sensors, the key idea is that pressure causes a physical change, like bending, moving, or deforming, that can be measured electrically. Engineers design circuits that amplify and filter these signals so they can be accurately read by computers or control systems. These sensors are used everywhere, from monitoring tire pressure in cars to controlling industrial machines and even medical devices like blood pressure monitors. So, in essence, pressure sensors measure how gases or liquids push on a surface by sensing tiny mechanical changes and turning those into electrical signals that electronic systems can understand. It's a clever way of turning physical force into digital data.